I'm Anil Kumar. We will discuss another very important property of Pascal's triangle. We are calling it property 2, sum of consecutive entries. So let's put the Pascal's triangle in place. We start with 1 and then we move on, and to get the next row we kind of add the previous 2, right? So 1 plus 1, so 1 on the side, 1 plus 1 is 2, and then 1, and then we just move on like this. So what do we notice here? We add the previous 2 to get the next one, right? So that is the strategy, right? 1 plus 2 is 3, 2 plus 1 is 3, 1 here, and likewise we can expand this particular Pascal's triangle, and that's the beauty of this, right? So that is how we kind of expand. So what we learn here is that these numbers in the Pascal's triangle could be related with binomial coefficients, and since the sum of previous 2 is the same as the next one, we could write it in a formula form, that is NCR plus NCR plus 1 is equal to N plus 1, that is the next row, right? CR plus 1, right? So as you see here this is row number 1, 0, then 1, 2, 3, 4, right? So these are the different rows, n values, correct? So here the n value is 0, then we have n equals to 1, this is n equals to 2, this is n equals to 3, and so on. So if you add these two terms, which is 3C0 and 3C1, what you get is 4C1, correct? So that is what the formula is. You could actually prove this formula using NCR equals to n factorial over r factorial times n minus r factorial. So you can actually use this formula to prove this particular rule or property, right? So I hope that helps you to figure out how to get the next term using binomial coefficients, correct? So that is how it is. As an exercise, I'd like you to prove this particular formula, which is NCR plus NCR plus 1 equals to N plus 1 CR plus 1. Thank you and all the best.